Since the beginning of time, we've been trying to scale ourselves to the great unknown of space. The first telescopes, if you want to call them that, were just sticks and stones lined up with reference points of light in the sky, called stars. We used this technique for thousands, if not millions of years. Stonehenge, the pyramids of Egypt, and many other ancient sites had been used to count and follow stars, whether it be our own sun, Sol, or Betelgeuse. This technique only started to phase out when Lippershey invented the telescope. Hans Lippershey invented the telescope in 1608. At first, telescopes were weak. They only had a 3 times magnification level and were more likely to be used to view ships than stars. Then, Galileo got one in 1609 and greatly influenced the design. He managed to get his telescope to have a 33 times magnification level. He used this telescope to view the moons of Jupiter. This completely changed our view of the universe. It changed our view of the solar system from a geocentric model to a heliocentric model. After that, in 1668, Newton develops the first functional convex mirror telescope. In earlier versions, the viewer's head would obstruct the mirror, making it useless. Newton designed the first working version, and it had a small mirror on the side of the device that is large enough to let you view what the telescope is pointed at, but small enough so that you can still use it. Newton's new telescope had a 38 times magnification. Now here's a clip from periodic videos to help explain this further.
But I'm going to tell you about the metal of the mirror. And the mirror is made from a metal that is called speculum. Speculum is not an element, it's an alloy, a mixture of metals. And it's a mixture of tin and copper. Now you can see the problem straight away if you're making a mirror to look at stars and things is that copper is coloured, it's red or reddish colour. And for a really good mirror you need to have it absolutely colourless so that you see the actual colours of whatever is in space. The moon looks the right colour. It just happens that if you mix 2 parts of copper with 1 part of tin and just put in a little amount of arsenic, and obviously I'm not in a lab so I haven't got any arsenic here, you can get a metal which has been known for perhaps a couple of thousand years called speculum, which gives you a really nice mirror finish. Speculum is the Latin word for a mirror.
It's not a very good mirror.
Well, when it was first made it would have been polished and it would have been really good, and you can still see the traces of its polishing. So what's amazing about this is how heavy the metal is. Copper is quite a dense metal and so is tin. So this is much heavier than the modern mirrors that you would have, which are made out of aluminium, which is very light. And this mirror fits in the back here, so the light comes into there, onto the mirror and back again, and here is the eyepiece. So you look in there. And if you look at Isaac Newton's drawing here, you can see there's a picture of his eye. I don't know whether this is Isaac Newton's eye or somebody else's. So you can see here's a large ball, which is quite a clever mount that allows you to turn the telescope in whatever direction you want. And I was quite mystified because there's a little crown down here. And I wondered why on earth in a telescope you should need a crown. And our librarian explained to me that Newton tested his telescope by looking at some architectural feature in Cambridge on another building. And here is an indication that he drew to show the magnification, how much bigger the image was. And this is what it looked like to the naked eye, and here's what it looked like through his telescope. So it really worked.
The next big step in telescope design came from a person named Cassegrain in 1672. Cassegrain improved the design by adding another convex mirror into it. This moved the viewing piece from the side to the bottom. This made it have a slightly better magnification and allowed it to become slightly shorter. Both telescope designs got larger and larger until about the 1890s, where refracting telescopes reached their critical mass. The lenses on them got so big that they would sag in the middle and distort the lens, making them impossible to focus. This is why large ground-based telescopes that are used for scientific research are always reflecting telescopes, not refracting. In 1910, telescopes and spectroscopy combined to form a telescope that is able to tell the composition of what it looks at. This is actually how we discovered helium, from the root word helios, meaning sun. Using this method, we have used it to discover what the composition of other planets in our solar system are, such as the moons of Jupiter or Venus. Nowadays, we have adaptive optics. Adaptive optics are just reflecting or refracting telescopes that can bend and adapt their mirrors or lenses to change their focus. This is often used to compensate for humidity or air distortions to get the best image possible. One of the most important discoveries of our view of the universe occurred when Edwin Hubble discovered that the Andromeda Nebula was actually a galaxy. He also discovered later in his career the redshifting that occurred in faraway galaxies that proved the universe was expanding. This drastically changed our view of the universe from just our galaxy to our view today of a nearly infinite, expanding universe. The next biggest step occurred when we lost our atmosphere. Space telescopes help us see farther out into space and farther back in time by eliminating the distortion and light pollution caused by the Earth's atmosphere. The Hubble Space Telescope was launched on April 24, 1990, and repaired on December of 1993. The Hubble Space Telescope allows us to see farther out into space and farther back in time, showing us that the universe is much larger than previously imagined, and that even relatively empty parts of space contain thousands of distant galaxies. It also showed that most galaxies are anchored by a black hole in the center of it. It also helped us more accurately calculate the age of the universe to be about 13.7 billion years old. We also use Hubble to help us create a 3D map of dark matter in the universe. And finally, it also opened the door to discovering exoplanets and detecting their atmosphere, which is work carried on by the Kepler Space Telescope today. The Spitzer Space Telescope was launched August 25, 2003. The ability of Spitzer to detect colder matter in the universe is due to its infrared design and allows us to study gas clouds, dust clouds, and other colder matter in space to better understand how stars and planetary systems are formed. It also has the ability to detect extremely cold or faint objects and allowed us to observe some of the earliest formed stars and discover the nebula surrounding the black hole at the center of our galaxy, known as the Double Helix Nebula. The Kepler Space Telescope was launched on March 7th of 2009 and very accurately measures the minute changes in light intensity as planets pass in front of their host star. It also detects, through spectral analysis, the planet's atmosphere and composition of that atmosphere. So far, we've discovered thousands of exoplanets around other stars and a few atmospheres that may harbor life, suggesting that there are billions of habitable planets in our galaxy alone. This number, multiplied by the billions of detected galaxies and the age of the universe, makes other life in the universe almost a certainty. The James Webb Space Telescope is projected to launch in 2018. It has a large 23-foot diameter infrared telescope with advanced cryogenics, folding mirrors that are adjustable after launch, and lightweight beryllium optics. It also has ultra-sensitive detectors which will be able to capture extremely weak signals, and microshutters enabling programmable object selection for spectral analysis. The James Webb Space Telescope's mission is to advance the work of Hubble, Spitzer, and Kepler space telescopes by identifying the first bright object that formed in the universe, and to determine how the universe evolved to its present state. by focusing on the birth and early development of stars and the formation of solar systems, and to study the composition of the solar system to determine where the building blocks of life might exist. To conclude, through astronomy and the evolution of the telescope, mankind has gone from believing that we are the center of the universe to the realization that we're just a tiny speck in the vastness of space-time. Our knowledge of how the universe is formed, how old it is, what it's made out of it, and how it operates has grown exponentially in just the last 50 years. But for all we've learned, there's more that we don't know. Perhaps with all the new technology planned for the next generation of telescopes, next-gen astronomers will be able to narrow that gap. And who knows, we may even find somebody to help us with it.